Hello, Dr. Janeja, and welcome to Computer Science Chats. How are you?
I'm doing well. How are you, Victor?
I'm doing great as well. Thank you. So I prepared several questions to ask you. So first, could you please introduce yourself and your educational background?
Sure. So my name is Vandana Janeja. I'm professor and chair of Information Systems Department at UMBC. My background is in information systems, and my focus area of research is data science, where I've been looking at complex heterogeneous data sets and identifying patterns, non-trivial patterns in them. My PhD was from Rutgers University many years ago now, in the area of information technology. And before that, I also did a master's from NJIT in computer information systems. I had a meandering path because my undergrad was in geology, but I
Thank you.
landed up in information systems. Yeah.
Yeah, so what is it that inspired you to pursue data science?
Mhm. So when I was doing my master's at NGIT, I took a very interesting class in data mining, and that was when this was around 2001, I believe, and that's when data science was just like emerging as a field. And this was also around the time of 9/11, and I started talking to a professor at Rutgers, and they were talking about the complexity of the data sets that they're seeing, especially in the domain of homeland security. And they wanted to make sense of that data. So I started talking with my future advisor at Rutgers, and also a professor who was looking at the federal aspects of the data sets that are there. And working with both of them really inspired me to think about data in different ways, and the power of data, and really all the things that you can do with data, and all the good that you can do as well. So that's why I got into the field.
That's very interesting. So how would you describe data science or data analytics?
Yeah. So data science is really a science of discovering non-trivial and actionable patterns from data. And notice I just say data, I don't say massive data, because many times people assume that data science is only about massive data. But there's lots of other perspectives to data science, where you have data which is heterogeneous, it can be complex, complex in the form of, let's say, data from spatial data sets, temporal data sets, image data sets, or they may be coming from different domains, and they're heterogeneous in that sense. So data science is really the discovery of non-trivial and hidden patterns that can be actionable for you to act on to do some task. It could be finding new drug combinations that work for certain diseases which have not been tried, or they could be patterns that you have missed in, let's say, your communication logs and so on. So lots of different applications there.
That's very interesting. What are some of the challenges in data science?
So I mentioned data being heterogeneous and complex. And, way back in the beginning, when I took my first data mining class, data sets used to be very simple and, like a single Excel file coming from one source. But data, as we know, comes from many different sources and can be related. Making sense of all of that data together for a question that you're trying to answer or investigate is what's really challenging and complex. And the reason of that complexity also comes from the fact that these data sets can be coming from different domains. So even if you're investigating, let's say, deepfakes and how audio files can be corrupted to create things that look real but are not, you also have to look at the social aspects of it and the linguistics aspects of it. So it's not just a data problem, it's also a linguistics problem. So bringing in those domains can be very interesting, but also challenging to put together.
Thank you. So what do you like? So could you describe some of the activities that you do through your work?
Yeah, sure. So my activities span a spectrum of research and teaching, and also managing several projects. I do more of that nowadays than the core teaching, but at the same time, I really enjoy that. So I've taught several graduate classes and undergraduate classes in data science. I've created new curriculum, programs for students in these areas of data science, informatics, to name a few. One example was the foundational data science class that I just created at UMBC, and it's open to all majors at UMBC. And it sees students from all kinds of interesting fields like theater and psychology and finance and economics. And that's really fun to teach students from their own background and their own perspectives and context, how data can be manipulated and managed, and discovery of patterns can take place. So that's one bit of it. But the other big chunk of my work is also researching into new areas of data science, like deepfakes was one example I mentioned. I'm also working on a project for harnessing the data revolution for the polar regions and looking at climate change and how we can do data science for climate change, understanding of climate change in the polar regions.
Thank you. I noticed that you have an upcoming book on data analytics for cybersecurity. And I read in the overview that you advocate for data analytics approaches to non-traditional views of cybersecurity. Could you just explain what that would entail and maybe give a brief example?
Yeah, absolutely. I'm super excited about that book. It took a while to get out there. And I think cybersecurity is another example where you have to look at security from a multi-domain perspective. So if we just look at how security is set up through firewalls and intrusion detection systems, you can miss out the human element of it. How is the attacker thinking, or how are they perceiving a threat to the system? So looking at, let's say, human behavioral aspects and the technological aspects together could be very interesting. And just like the deepfake example I gave, when you have audio clips which are made to sound real, we just focus on the AI algorithms that detect whether it's fake or not. And by that time, the adversary has already created a new type of fake to beat your system. But if we create a way of thinking around discerning for deep fakes, which takes linguistics into account, or gives you more information of, here's an intonation that sounds different, or here's a pitch that sounds different. So it thinks of the problem differently. I think that's the way we should be approaching cybersecurity problems, is bringing these human elements to it, bringing these social aspects to it. And ethics is a big part of that as well. Thinking about how ethical thinking can bring about a change in data science too.
That's very interesting. So I know you were talking about this earlier, but I read your recent paper on audio deepfake perceptions in college students, where you tested to see if college students could recognize audio deepfakes. What inspired you to focus on college students in particular?
Yeah, I think we are all bombarded by stuff on social media. We see this all the time. We get forwards from different accounts. But I think more than anyone, college students face that a lot. You would be on social media more than I would be. At least that's my perception. And I think understanding how college students think about it gives us a window into how people would generally think. And we obviously want to expand the study to more, general population. But we started with the college-going population. And also because this study was really inspired by two of my students, Gabrielle Watson and Sarah Khanjani. And Gabrielle actually really, started this idea of, she herself was a college student, and we had lots of conversations around it. And we thought to start there because you all probably see the most social media than others. And you might have more questions of how to perceive deepfakes than others.
Thank you. So changing the focus a bit, I noticed that you worked both as a university professor and as an expert for the National Science Foundation, a government agency. How do these roles compare?
Mm-hmm. Yeah, that's an interesting question. And I think a lot of the research work that I do as a professor spills over into the expert role, because when I looked at things as an expert while I was at NSF, I had to put that hat of a researcher as well. And the expert role also helped me think of new directions of science, what I would like to create. And I worked with some amazing people at NSF, thinking about, visioning about these new directions. How do we bring data science to the community at large? How do we connect data scientists to these community folks who would need the use of data science? Or how do we cloud credits accessible to everyone? So those are like deeper questions that change the way we work in this field and the way data science become accessible to everyone, rather democratizing of data science. So that was a little bit of a difference there, because you have the high level view at the federal scale and what's working, what needs to be done. So visioning of new things was a lot more involved at NSF versus the core research focus I have in my lab, for example.
Yeah, what advice would you have for high school students who would like to get into data analytics?
Yeah, that's really great. I have a high schooler as well, so hopefully, that advice applies to other high schoolers out there. I think the first and most important thing is be inquisitive and really look around yourself, and you might see problems that motivate you. If you force yourself to think about what fits, line on my CV or resume, that's only going to take you so far. But if there's something that really interests you, and you investigate that, that will take you further. And if you find things around you, phenomena around you that puzzle you, look for data sets for it, and explore those data sets as a hobby, instead of Legos that you would do in the early elementary school. Now you have these data blocks that you can explore and investigate. And it data could range anywhere from movies to game statistics to astrophysics to climate change, any of those. And that's the beauty of it, that if you develop some foundational coding skills, and there are many, many courses out there that actually help high schoolers learn those things, and some of the high school curriculum also has that, you can apply those coding skills to exploring data. And I'm talking especially about data science careers and thinking about data science, but connecting it to your interest would be my best advice.
Thank you. I also noticed that you have worked on projects that strive to increase diversity in STEM fields in general and computing in particular. I understand that some of the challenges of building a diverse and inclusive computing community can be addressed as early as K-12 schools. In this context, what advice would you have for a high schooler such as me in terms of the things that I can do to support such efforts?
Yeah, that's a great question. I think diversity starts very early, like you said. Thinking about diversity starts very early, and you can have a lens of diversity in everything that you do. So pretty much all the projects I talk to you about, I always have that lens of thinking about equity, inclusion, diversity, and how can I engage more students. The foundational data science class I talked about also looks at that, because data science is not an elite field that only a certain few students who can do programming can get into it. There's so many tools now for data science that are accessible to many individuals, and they can play with them. And it's click and drag and drop type of interaction, which is really accessible. For you as a supporter, I would say, being a strong ally, having, including partners on your projects as a very, small example, making sure that you recognize backgrounds, you recognize and respect differences, and invite opinions and thoughts. Well, discourse is a very important piece, even though we're talking about programming and data, but data can come from many fields, and having diverse opinions about that is very important. And many people forget that, that you're thinking about data, but you have this one mindset of creating a certain algorithm. But having different types of people on project teams will actually bring out perspectives that you may have never thought of. So being an ally and creating project teams that are diverse could be a place where you can start with.
That's very interesting. And so where do you think that data science is going to go in the future?
I think, way back when from the 2001 example I gave to now, we are drowning in data. There's no question about it. At the same time, this data is messy, heterogeneous, complex. So data science is moving in a direction where people are recognizing these complexities and addressing them. And once we start bringing together these heterogeneous sources is when some really fun and interesting data science can happen. And it's already happening in many of the actionable things that we're seeing. If you pick up any of the newspapers now, they're talking more about data than ever before. COVID taught us that, we all are familiar with how to read graphs now, or many of us are familiar with how to read graphs now. which was, limited to professionals who would be doing that as their job. So that's going to become more mainstream. People are recognizing that. And with the advances in the technology that each of us uses, we also have to recognize things like privacy and ethics. There's going to be more discussion around that. But I think it's going to be empowering to users to be owners of their own data and recognizing how they can control their data. So some of those important conversations are definitely going to happen in the near future. And the last bit I'll also say is we've been talking about breaking silos for a while, and I do hope that that's really going to take place with data science across domains and data science incorporating many of these heterogeneous data sources.
Thank you very much for meeting with me and for being willing to do this interview.
Absolutely. It's a lot of fun. Thank you for doing this.
Thank you.